Good morning, students. In chapter Human Eye, the Colorful World, we have learned about the structure of the human eye, how human eye work, and what are the effects of vision in human eye. And then we have learned about glass prism, the structure of the glass prism and how it works. What is the spectrum of white light, and why the light get dispersed, or we can say why it get dispersed into seven colors when it passes through the prism. In last lectures, we have studied about atmospheric refraction, how the refraction takes place in the atmosphere, what is the reason behind it, why the reflection of the light takes place when it enters into the atmosphere. And then, now the last part of the chapter is the scattering of light. Yes, we have also studied about different reasons behind why stars appear higher than they actually are, why the stars create the planetary moons. Now the last part of the chapter is the scattering of light. So now we are studying about the scattering of light. What is the meaning of scattering? Scattering is when the light is scattered, it gets dispersed, it gets scattered all around. Means when the light falls on different particles of the atmosphere, it gets scattered. And this is also called the Tyndall effect. You have studied about the Tyndall effect in class 9 in chemistry. You know that Tyndall effect is shown by suspended particles as well as the collided particles. True solution does not show the Tyndall effect. Tyndall effect means the scattering of light is called Tyndall effect. Now the different particles of atmosphere scatter the light differently. So we have two types of particles in atmosphere. We can divide the particles into two parts. Not only two types of particles are there. We can divide the particles into two parts. One the smaller one and the larger one. Okay, one more example for the scattering of light is when a light enters through a small hole in your room, you are able to see the path of the light. How is it possible? It is due to the scattering of the light. Since the light is scattered and then falls on our eyes, and then we are able to see the light. So, for this scattering of light, first we should understand that we can divide the atmospheric particles into two parts. First one is the small particles, like the gaseous particles. You know that atmosphere is made up of different gases, nitrogen, oxygen and different gases. So, atmosphere has 78% of hydrogen. So, these gaseous particles are very small in size. Since they are made up of molecules and we know that the size of the molecules are so small. So we can say, we can divide the particle size, we can divide the particles of atmosphere on the basis of their size into two parts. First is smaller particle. Smaller particles in which we can say it can be gases of air. These gases of air or the particles of gases are very small in size. So they scatter the light which having the shorter wavelength. Okay, I think I should explain you about the wavelength because this is a part of the chapter sound last year. In class 9 you have a chapter sound in which we have studied about wavelength. But there is a drawback with you that you did not study the chapter sound. Because of corona, this chapter what is deleted. So first let me explain you what is the wavelength. Wave is this form is called waves. Like when we throw a stone into the water, a waves are formed. This is called the waves. So these waves can be divided like this is called crest. The upper part of the wave is called crest and the lower part is called trough. So the waves are travel in this form. Such like electromagnetic waves are also travel in this form. Here the distance from one part to this part, it means the whole length from here to this part is called wavelength. Or we can also define it like the distance between the concentrated crest or the concentrated trough is called the wavelength. So this is called wavelength and we represent it by using a symbol lambda. It's having the SI number meter. So the light is made up of we know that visible light we are able to see made up of several colors. With you, these seven colors having the same speed in A, but its speed different in different medium. As well as the wavelength of different color are different. The blue color, which is in the starting, or we can say the violet color, having the shortest wavelength. So it has the short wavelength. And the red color of light having the longer wavelength, or we can say longest wavelength. Longer wavelength. So first we should know that this blue color light having the shorter wavelength, whereas this red color light having the longer wavelength. Now what happens when the light travel through the atmospheric gases, like when they strike the atmospheric gases, these small particles scatter this blue light, not this red light which having the longer wavelength. It is scattered only the blue light which having the shorter wavelength. So we have to learn that when the light passes from the gaseous particles, the small particles, the blue color of light which having the shorter wavelength gets scattered, and the red color of light having the larger wavelength do not get scattered. So one thing we should remember. So first one, the scattering of light happens due to the atmospheric gases. Second one, atmosphere has different size particles, like these tiny particles, the gaseous particles, as well as the larger particles, or we can say the dust particles. Since the size of the dust particles is more as compared to the gaseous particles, so we can say the larger particles. Large particles. And these large particles are, these can be dust particles. Dust particle, moisture, water vapors. So the second one, the large particles. These large particles, or we can say dust particles or water vapors, they scatter the light as it is. It means they scatter the white light as it is. It means the light after scattering also becomes light, white sorry. So the white light is scattered as it is by these large particles, and it appears to be white. So for scattering of light, one we should know that what type of particles are responsible for scattering of light and how these particles scatter the light differently. Okay. So now let's talk about some phenomena which happens due to this scattering of light. First one, why sky is blue? Why sky is blue in color? So first, we should understand that with the light entering the atmosphere, it is strike the different particles of atmosphere, like the gaseous particles. These gaseous particles scatter the blue color of light most. So that's why if there is all around there is a blue color only, so we are able to see the blue color light. You know why we are able to say this duster is yellow in color? Why it looks like yellow? It appears to be yellow because when the light falls on the surface of this duster, it absorbs all the other colors except yellow. So the yellow color is not absorbed by this duster and it reflects. After reflection from this duster, the yellow color enters into the eyes, and then we are able to see this duster yellow in color. So that same happens in case of blue sky. When the light enters into the atmosphere, most of the blue color, which having the shorter wavelength, get scattered by the atmospheric gases. So that's why it's appeared that the sky is blue in color. The same thing happens in case of sea, a large oceans. They are also appear blue in color because this blue color gets scattered by the atmospheric gases, and then since this blue color enters into our eyes, so we are able to see everything blue, like the sky and the oceans. So okay, one question. This is give reason type of question. Give reason. what should be the color of the sky from outer into the atmosphere? Yeah, we can say if we go into the space, what color of a sky we will see. Actually, if we move out through the atmosphere, since there is no gases, if there is no gases, the scattering of light will not happen, or if the light will not get scattered, hence we are not able to see the sky blue in color. Again, you should know that the sky appear blue because this blue color gets scattered and then enter into the eyes, and then we are able to see the sky blue in color. And what happens if we go into the space? In a space, since there is no atmosphere, so the scattering of light cannot be possible. Since the blue color do not get scattered, so we are not able to see the sky blue in color. It appears to be black. So in the outer space, the sky appears to be black. So the question can be the reason why sky appear black in color in outer space. Why the sky appear black in outer space? I think now you understand what is the reason for it. Other given reasons are, what can be the other questions? Okay. Why the danger signals are blue in color? We have seen that the danger signals are blue, not the blue, red in color. So why the danger signals are red in color? We have to see the danger signal from the large distance. We know that all the other colors which have the short wavelength, like the blue as the shortest wavelength, then the other colors may pure. Out of these 7 colors, the blue color having the short wavelength, so it is scattered most than the other colors. And the red color which having the longer wavelength do not get scattered by the atmospheric gases. So, since this red color line do not get scattered by the atmosphere, so it can travel the large distance. Just imagine if you make the danger signal blue, then what will happen? This blue color gets scattered into the in a short distance. Suppose you are able to see the sun. Why you are able to see the sun? Because the light travels from the sun, when falls into our eyes, we are able to see the sun. What happens if the danger signal is blue in color? This blue color gets scattered in the path, so it travels a very short distance. In a short distance, all the blue color gets scattered. So that's why it do not travel the large distance, and we are not able to see the signals, blue color signal for the large distance. But in case of red signals, since red color having a longer wavelength, so this red color do not get scattered, and this color can travel the large distance, so we can see the danger signals from a large distance. Okay, so one question is, why danger signals are red in color? Okay. Why danger signals are red in color? Now I think you understand what is the reason for it. Now let's talk about, you have seen many times that at the time of sunrise and sunset, the sun appear to be red, but at the time of noon it appear white. So what is the reason? Actually, at the time of sunrise and sunset, first we should understand what is the meaning of sunrise and sunset. This is the sun. And we know that our earth revolves around the sun. So this is our earth which is revolving around the sun. This is earth and this is sun. If we are here, so that we are not able to see sun, this earth is revolving as well as rotating on its axis. So when it rotating on its axis and we are here, we will say it is night. When this earth rotates, sunrise. Again, in revolution as well as in rotation, when we are here, we will say that it is noon. And after the revolution, when we are here, and after revolution, what is rotating like this? So we will say this is the night. So first we should know what is the meaning of the morning and the evening. Yeah, at the noon. So now you are here in the morning. So I have to rub this board. So this is Earth, and suppose this is Sun, and now you are here. This is the time of morning. We know that our Earth is surrounded by the atmosphere. So suppose this is the layer of atmosphere. Actually, we don't have the layer, but we can divide it for our convenience. So this is the atmosphere. Now, at the time of morning, as well as in the evening, the sunlight has to travel the large distance like this. And what happens at the time of noon? At the time of noon, you are here. So this light has to travel a small distance through the atmosphere. This is the distance light has to travel in the time of morning in atmosphere. And at the time of noon, the distance traveled by the light through the atmosphere is less as compared to the morning as well as of the evening. So one thing we should know that at the time of morning as well as at the time of evening, yeah, at the time of sunrise and the sunset, light has traveled the large distance through the atmosphere. But at the time of noon, the sunlight has to travel the small distance through the atmosphere. Now, what happened if the light has to travel the large distance or the small distance through the atmosphere? When this light has to travel the large distance through the atmosphere in the morning as well as in the evening, this light, the many colors of light except red, since it has a longest wavelength. So many colors of light get scattered in the path. This large distance through the atmosphere light has to travel. So in traveling this distance, light gets scattered. Now the light gets scattered in the path at the time of sunrise and sunset. Only red color of light, since it having the longer wavelength, since red color light having the longer wavelength, so it do not get scattered and it reaches our eyes so that we are able to see the sun red in color. Again, you should know why different objects appear of different color. Suppose a rose appeared to be red. Why it appeared red? Because when the light falls on the rose, all the colors except red is absorbed by the rose. And only the red color do not get absorbed by the rose, so it gets reflected by the rose and then we are able to see the rose red in color. So same as the sun appeared red because only the red color light moves through a distance and reaches our eyes so that we are able to see the sun red in color. Now what happens at the time of noon? At the time of noon, the light has to travel a small distance through the atmosphere. Now in traveling this short distance, most of the light do not get scattered. Only the small portion of this blue light gets scattered, and if we combine all the 7 colors of the light, except one, except blue light, it appears to be white. So that's why the sun appears white at the time of noon. Once again, when the light at the time of noon, the light has to travel a small distance through the atmosphere. So most of the color do not get scattered, only the small portion of the blue light gets scattered, and that's why the sunlight appear to be white, or we can say sun appear to be white in color. So these are some phenomena which are responsible, which are based on the scattering of the light. Okay, like one more question. Question number 4. Why noon. Okay. Now I think you understand the reason why it happens. Or in case of any doubt, you are not going to understand what is I am explaining here, then you can ask me in the Google Meet class. So okay, there is an experiment to show that the blue light gets scattered most and the red color light gets scattered least by the particle size, by the different size particles, by the different particles of different size. So this is the experiment from NCERT book. So in this experiment, we make a suspension. Now in last year, in chapter 2 chemistry, you have learned what is a suspension, what is a collider, what is blue solution. Now we know that suspension is scattering the light. So we make a suspension in a beaker. This is a beaker in which we take water with sulfur particles suspended in it. Sulfur particles are we take water with sulfur. Water plus sulfur. So we have the suspension in this beaker. Now we take a convex lens. Convex lens is a conversing lens. So there is a white source of light. This is a source of light. White source of light. We know that the white light is made up of 7 colors. We place this white light source at the focus of this lens. Now when the light is scattered and falls on this lens, what will happen? We know that this light will be parallel. This light ray will be parallel to each other when it passes from the convex lens. Since we place the white light source at the focus of the lens. So these light moves parallel to each other like this. Okay. And now again we place a convex lens here. So then all the light rays which are coming from this beaker get converged at a point, which is called focus. So after passing through this solution, or we can say suspension, this light again falls on the convex lens and we place a screen here at the focus of this lens. And what will we see now? When the white light gets scattered by this lens, it passes through this suspension. This suspension has sulfur particles in it. Sulfur particles are very small in size, but they do not get dissolved in water. So what happened? The suspension, the sulfur particles, is scattered the blue light in the path. So the blue light color gets scattered here when it passes into the suspension, when it passes into the solution. And what will we see? On this screen, there is only the red light spot. Red spot. We send the white light as a source and we get only the red light. What is the meaning for it? It means that all the other colors get scattered in the path by this solution. So this experiment showed that the blue color of light having the shorter wavelength gets scattered most, and the red color of light, since it has a larger wavelength, it do not get scattered. So we get the red color light at the last in the screen. So this is the experiment of NCERT book. Now, okay, one question from my side is, why clouds appear white in color? We know that the color of the clouds is not actually white. They are made up of water vapors. Is water vapors white in color? No, not at all. So why clouds appear to be white in color? This is question from my side and you have to answer me in your meet class. Now chapter finish, we have to finish our chapter. And we will do some experiment. If the school will open, we will do some experiments on concave and convex lenses. have an experiment from this chapter, this glass prism. How the glass prism deviate the light. We have learned about the angle of deviation, yeah, how the light get deviated when it passes from the prism. So we will do this experiment if we are able to come into the school. We can see if you are able to come to the school, then you can do this experiment. So there is a lots of portion in the second part of the chapter, that is a concept of refraction as well as the schedule of the light. So we have the lots of different type of questions. So okay, now we have finished our chapter. Now in the next class I will start a new chapter of physics, that is electricity. Yes. So we will start the new chapter in the next class. So now we have finished this chapter, human eye and the colorful world. In case of any doubt on the whole chapter, you can ask me in the Zoom class, not the Zoom class, sorry, the Google Meet class. Okay, have a good day.